continue with signum function. I think yesterday we have completed 3 transformations. I'll just revise. What are the transformations we have covered so far? First one is shifting, right? In shifting, I explained you 2 types of shifting. One is horizontal, other one is vertical. Do you remember this? It is like from f of x graph, drawing f of x plus a, drawing f of x minus a, f of x plus a, f of x minus a, isn't it? And the second one, what was the second one? From f of x, f of mod x. And the third one, from f of x minus f of x. And the fourth one, from f of x, drawing modulus f of x. I hope you remember the rule for each and every transformation, right? So, these are the basic transformations. And then yesterday we have also discussed signum function, isn't it? But today, let us try to understand few questions on signum function as well as logarithmic function also, based on the time. Now let us try to solve this question, which was there in your material. The range of f of x equal to signum of 2 power x plus signum of modulus x minus 5. Very simple question, basic question. Uncommon, maybe. What is the value of this one? 1. What is the value of this one? 1 or 0? It can be 0 also, right? Yesterday I told you. Right. Now, look at these two functions separately. Solution. Signum of 2 power x is definitely equal to 1. Why? As 2 power x is always greater than 0. The exponential function. A power x is always greater than 0. Do you remember that? Now, in the same way, I hope you understood why signum of 2 power x is equals to 1. Because 2 power x is an exponential function, and exponential function is always positive, right? And if you remember the definition of signum function, what is that? I'll write it again. Signum of x is equals to 1 if x is greater than 0. 0 if x is equals to 0. Okay. Minus 1 if x is less than 0. Right? Plus 1 if x is greater than 0. 0 if x equals to 0. Minus 1 if x is less than 0. So in the same way, 2 power x. 2 power x is positive, right? So definitely if x is greater than 0, signum of x is 1. Correct? And similarly, signum of mod x minus 5. This one also we have explained yesterday. This is equal to 1 if modulus of x minus 5 is greater than 0. It is like signum of f of x is equals to 1 if f of x greater than 0. Do you remember that? 0 if f of x is equals to 0. And minus 1 if f of x is less than 0. And obviously modulus of anything cannot be less than 0. So this case will be discarded. This is not possible. Therefore, signum of modulus of x minus 5 is equals to 1 if, what about this one? When does modulus of x minus 5 greater than 0? For all x belongs to R except 5. Isn't it? Except 5 is greater than 0 for all real numbers. 0 if x is equal to 5. Because modulus of x minus 5 will be equal to 0 if x equal to 5. And signum of 2 power x is 1 for all x belongs to R. Isn't it? So, from here it is very simple. We just have to add these two functions. Therefore, f of x is equal to, add this one and this one. So what are the two possibilities? 1 plus 1, 2. Similarly, 1 plus 0, 1. So definitely f of x can be either 1 or 2. So definitely range of f of x contains only two elements, either 1 or 2. Understood? Please go. This is the answer. So this is the range of f of x. More clearly, if you want to write like the signum of 2 power x plus signum of modulus of x minus 5 will be equal to 1 plus 1 if x belongs to all real numbers except 5, right? That is 2 if x belongs to all real numbers except 5. 1 plus 0, 1 if x is equal to 5. So this is the complete description of the given function f of x. Signum of 2 power x plus signum of mod x minus 5 will be equal to 2 if x belongs to all real numbers except 5, which is equals to 1 if x is equals to 5, right? Please copy. Continue. Okay. One more question. Copy. Find the range of, next question. Find the range of f of x equal to modulus, read it properly. Modulus ln mod x. Ln means I already told you base will be e. Okay, log e. Find the range of modulus of ln mod x. So how do you solve this type of questions? Closed zero or open zero? Correct. Right. Usually this type of questions, I solve this question using graphical transformations. Yesterday I told you, right? Draw the graph and tell the answer. By using graphs also we can find domain range. Especially for finding the range, Most of the times we will use graph source depending on the given question. And you draw the graph of modulus of ln mod x. Understand? It is like here the steps are something like this. To draw the graph of modulus of ln mod x, first you will draw ln x graph. From ln x graph, I will draw ln mod x. And after getting ln mod x, I will draw modulus of ln mod x. So these are the three steps to be followed to draw the graph of modulus of ln mod x. Okay, right. We will start with ln x graph. Ln x graph will be something like this. Correct. This is one. And yesterday I told you, if you want to draw ln mod x, it is like f of x. This is f of mod x, and this is like modulus of f of mod x. Is that correct? Right. Now what I do is, how to draw f of mod x? I should remove negative x-axis part. Do you remember the rule? But here there is no negative x-axis part. Yesterday also I have drawn this graph, ln mod x. So we have positive x-axis part. And what we should do? What is the next step? We have to take the mirror image of this graph with respect to y-axis. So that graph will be something like this. I'm not wrong. Correct? Now this is ln mod x. This is ln mod x. Now after getting ln mod x, what should I do? I should draw modulus of this one. Now assume this one as f of x now. So this is one function, and graph of this function is this one. Okay. And if you know the graph of the function, how do you find the modulus of this one? I told you. Negative y-axis region. You have to take the mirror image of negative y-axis region with respect to x-axis, which means that this is negative x-axis region, sorry, negative y-axis region, that is which is lying below x-axis. Now I have to take the mirror image of these two graphs. So it will be, what will be the mirror image of this one? If you assume this one as the mirror, are you following it or not? Similar, what is the mirror image of this one? Something like this. So you don't get this one actually. So this is the graph of modulus ln mod x. Please let me know if you do not understand anything here. This is very simple. Once again, dotted one will not be included in the graph, okay? That's what we are writing. This is ln x. This will be ln mod x. And if you take the mirror image of these two parts with respect to x-axis, that will be modulus ln mod x. So our graph is strictly lying above x-axis. Understood? This is the graph. Is it clear? This is the required graph. Now tell me, by using this graph, what will be the range of this one? I told you range means y-axis. Vertically, you should look at the graph. Vertically, graph is lying between 0 to infinity. Is it correct? And horizontally, minus infinity to plus infinity. So no doubt, it is defined. Domain is all real numbers except 0. Because at 0, it is not defined. There is no graph. Is it correct? Because even if it x equals to 0, ln of mod 0, 0. ln is not defined for 0. Understand? Now what about range? Range means vertically. It is lying above x-axis, isn't it? So starting with 0, because at 1 as well as minus 1, its value is 0. And that is the minimum value, up to infinity. So range will be closer 0 to infinity. So this is the answer. I hope this is clear to everyone. Please let me know if you have any confusion here. So please learn drawing the graphs. Modulus of ln mod x. Draw ln x graph, draw ln mod x, and take the modulus of that function. Okay? Yes, 0 should be included, for sure. Right, look at the graph. 0 is included, right? At 1 and minus 1, what is this value of x value? 0. So 0 is also included in the range. at x equal to plus or minus 1. What is f of x value? Modulus ln modulus of plus or minus 1. Modulus ln plus or minus 1, 1. What is modulus of ln 1? 0. ln 1 is 0, right? So that will be the minimum value. Sir, at left of y-axis there are negative x values. So if you find a domain, we will do right. Tarun, I did not understand your doubt. Can you please rephrase your sentence? Right. Let us try to look at one more interesting problem. These are all very basic questions, okay? Okay. Tomorrow I'll explain greatest integer function. Draw the graph of, write down. Draw the graph of, draw the graph of y equal to signum of ln mod x. You can generate n number of questions, okay, based on the concept. You have that flexibility in objective exam. Graph of y equal to signum of ln mod x. See, I already told you whatever may be the question, do not deviate from the funda. Funda will be same, right? Now observe. Y means f of x. F of x equal to y equal to. Now signum of ln mod x. It is like signum of f of x. What is the formula? Signum of f of x will be 1 if f of x is greater than 0. You remember that? Signum of anything, that anything is positive, then signum value will be 1. 0 if ln of mod x will be equal to 0. Minus 1 if ln of mod x is less than 0. Now here comes the inequalities. Again, I'll write it once again. Log n to the base a equal to x, n equal to a power x. Do you remember the basic definition of logarithm? Don't forget this. This is very, very important. Now, ln means base will be e, right? I already told you e. E is greater than 1. And how to solve this inequality? I already told you if the base is greater than 1, inequality does not change. Is it correct? So here definitely base is greater than 1. It is like log n to the base e. So a mod x will be greater than e power 0. Are you getting it or not? If you want, you can write it as ln mod x base e greater than 0. N a x. N equal to a power x. Correct? So in the same way, 0 if modulus x equal to e power 0. In the same way, minus 1 if mod x less than e power 0, because base is greater than 1, inequality does not change. Now from here, it will be equal to 1 if mod x greater than e power 0, 1. 0 if mod x equal to 1. Minus 1 if mod x is less than 1. Correct? Therefore, if you simplify this one, signum of ln modulus x is equals to 1 if you remember the properties of logarithm, mod x greater than a. What is the meaning of that one? X less than minus a or x greater than a. I will write it once again. mod x greater than a, x less than minus a or x greater than a. Do you remember this property? Similarly, mod x less than a, x lies between minus a to a, mod x equals to a, x equal to, please revise your notebook once you find this properties. Mod x equal to a, x equal to plus or minus a. Now, 0 if x equal to plus or minus 1 and minus 1 if minus 1 less than x, right? So this is the given function actually. So getting this part is important. If you get this part, remaining thing is very simple. Now let us try to draw the graph. First thing, 0, 1, minus 1, 1, minus 1. First of all, when does signum of ln mod x is becoming 0? When x equal to 1 and when x equal to minus 1. Two dots. 1, 0, minus 1, 0. Correct? It is like plotting the graph. And when does it is equals to 1? 1 means horizontal line, isn't it? When x less than minus 1 and x greater than 1. X less than minus 1 means this one. And bubble because there is no equality. Because at minus 1 it is 0. Less than minus 1 it is 1. I hope you are following this. Similarly, x greater than 1 also it is 1. So again, corresponding to greater than 1. This is 1. Is it clear? X-axis, y-axis. Okay. Similarly, it is equal to minus 1 when x is lying between minus 1 to 1. Minus 1 to 1 means this one and this one. And this is minus 1. Is it correct? See, between minus 1 to 1, this is equal to minus 1. At minus 1 and plus 1, 0. And less than minus 1, greater than 1, it is 1. Is it satisfied? Did you understand? So this is the graph of signum of ln mod x. Here, signum of anything, range will be only either minus 1 or 0 or 1. Understood? See, minus 1, 0, 1. But the graph will be changed. Please let me know if you have any confusion in this graph. So this is signum of ln mod x. Once again, this analysis is okay, I guess. It is equals to 1 if x is less than minus 1 or x is greater than 1. 0 if x equal to plus or minus 1. Minus 1 if x is lying between minus 1 to 1. The meaning of this one is, for all the values of x less than minus 1, for all the values of x greater than 1, signum of ln mod x is equal to 1. Just horizontal line, corresponding to 1. Understood? Less than minus 1, greater than 1, 1. And at x equal to 1 and x equal to minus 1, 0. That's why I put dot here. Okay. And similarly, if x is lying between minus 1 to 1, f of x is, sorry, this one is what? Minus 1. So between minus 1 to 1, f of x is minus 1. Understood? Please copy this one. So this is the combination of signum function and logarithmic function. And I have a doubt. Is this graph correct? Is it the correct one? I think there is a mistake. Can you please tell me that mistake? Students, I am asking, there is a mistake in this graph. Can you tell me what is that mistake? If you tell me that mistake, I'll give you 5 star certificate when I meet you. 100%. Okay. There is some mistake in this graph. Can you tell me what is that mistake? I'll give you 2 minutes. Just think and tell me. Sir, we won't get negative values. Why? So? Log is not defined for negative values, but modulus x is there, right? So it will be defined for negative values also. Vishal, mod x is there. It will change the problem. Well, we should not include 1. Where? Here. Why? We are getting at x equal to, we are getting 0. At x equal to -1. -1. Tell me clearly. There is a mistake in this problem. Tell me what is it? Range cannot be. Why? Why can't it be negative? We are getting -1, right? Sigma function will get only 3 values: -1, 0, 1. Vishal, answer. What is the mistake? Other students? Pradeep, PT, Naveen, Sankhya, Bhavya. Bhavya is there or not? In meeting? No, she is not there. Meghana, Nancy. Of course, I cannot pronounce all the names, so I am asking each and every one. What is the mistake in this problem? Between the term between -1 to 1, the value would not be -1. Why? We just followed the definition, right? Why can't it be -1 between -1 to 1? Fine. You know. Huh?
Y-axis 1.
Here. No, less than -1. There is no equality, right? You should not. No, it is not. Okay, fine. I'll tell you. Signum of ln mod x. You know, I told you already. When you are dealing with the function, make sure that its domain is properly defined. Logarithm is there, right? Logarithm is defined only for positive values, isn't it? So we know that mod x is always greater than 0. For all x belongs to all real numbers except 0. What is the meaning of this one? In this graph is not defined at x equal to 0. But here we have drawn graph at x equal to 0 also. So that means here we have to put bubble. Understood? At x equals to 0, you don't get any graph because at x equals to 0, this is not defined, right? ln of 0, not defined. If ln of 0 is not defined, signum of ln of 0 is also not defined. So which means that here itself, mod x less than 1. And I should also put x is not equal to 0. So here, I'll write it like this. X belong -1 less than x less than 0 or 0 less than x less than 1. You understand? Instead of taking -1 to 1, I should break at 0. Because at 0, signum of ln mod x is not defined. So I'll write it very clearly. This is not defined at x equal to 0. Keep this particular point in bracket and write it very clearly. I hope you understand the problem now. At x equals to 0, you should not draw the graph, you should put a bubble. Why? At x equal to 0, function is not defined. Clear? But if you don't consider that, you will get the wrong graph. Here you will get dot. So when you put a dot here, you are saying that at x equals to 0, this value is equal to -1, which is wrong. Because at x equals to 0, function itself is not defined. Understood? Please go. Rohini K. Please repeat why was their graph wrong. Okay. Rohini, observe. I hope you understood this. This graph is not defined at x equals to 0. So in the previous graph, I have written directly minus 1 to 1, it is equals to minus 1. But between minus 1 to 1, 0 is also included. But I have to exclude 0. Reason, it is not defined at x equals to 0. That's why I am breaking this particular minus 1 at x equal to 0. Understood, Rohini? Simple reason, function is not defined at x equals to 0. Okay, good. Let's move to the next question. We will solve an inequality on signum function. See, I already told you there are so many applications, but due to time constraint and it is an online class, I am unable to solve more number of questions. Definitely when we start direct classes, I'll tell you more number of examples, don't worry. Because when we start direct classes, almost we will get 2.5 to 3 hours per maths. Okay. Per day. 2 hours teaching, 1 hour counseling. Doubts clarification. Okay. Right. Solve. Please take down this example also. Signum of, good example. Solve signum of x minus 2 by x plus 1 less than or equal to x minus 1 by 2. Right. Actually, this question can be solved in two methods. One is analytical method, second one is graphical method. For the time being, I cannot teach you graphical method because straight lines chapter is not yet completed. Okay, later I'll discuss that. Now, when you get this type of questions, the only important part in this question is understanding this one clearly. Signum of x minus 2 by x plus 1. That is, for what values of x, this function will be plus 1. For what values of x, this function will be 0. For what values of x, this function will be minus 1. Understood? If you understand this one, it will be very simple. So definitely I have to consider how many cases? 3 cases. Is it correct? So let me assume case 1. If signum of x minus 2 by x plus 1 equal to 1 plus 1, because we have only 3 possibilities, right? Either 1 or 0 or minus 1. Then if this is equal to 1, what is the condition? X minus 2 by x plus 1 will be greater than 0. Is it correct or not? X minus 2 by x plus 1 is greater than 0. It is like signum of f of x. Is it correct? Now, before solving this question, let us draw the sign scheme for x minus 2 by x plus 1. Where it is positive, where it is negative, using Wavy curve method. Because we have to solve this inequalities, right? Minus 1, 2. This one, x minus 2 by x plus 1. Now definitely it is plus, minus, plus. Correct? Now can I say that signum of x minus 2 by x plus 1 is equals to 1 if when x minus 2 by x plus 1 is positive, greater than 2, less than minus 1. Understood? If x is less than minus 1 or x is greater than 2. Are you getting it or not? So which means that if I continue to solve this one, this is equals to 1 when x it is less than or equal to x minus 1 by x minus 2 if x is less than minus 1 and x is greater than 2. So whatever solution you are getting, you should take the intersection of that solution with this one. Because we have started with this one, right? This is the restriction. x less than minus 1 and x greater than 2. Then only signum of x minus 2 by x plus 1 is equals to 1. So that means whatever solution set you are getting, it should satisfy this one. I hope this is clear to everyone. Now, how to solve this inequality is very simple. You can do cross multiplication directly because 2 is positive. 2 less than or equal to x minus 1. If I reverse this inequality, I'll get x minus 1 greater than or equal to 2. So from this one, x greater than or equal to 3. Understood? Now finally, what will be the intersection of these two? You know how to take the intersection. Minus 1, 2, 3. Correct? Less than minus 1. Greater than or equal to 3. Obviously, in this case, you don't get any intersection. And we have x greater than 2. What is the common region? X greater than or equal to 3. Therefore, x belongs to closed interval 3 to infinity. This is one solution. Understood? This is case 1. Are you getting it or not? Now, case 2. What is the case 2? If equal to 0, signum of x minus 2 by x plus 1 equal to 0, then when does this will be equal to 0? When x minus 2 by x plus 1 equal to 0, which means that signum of x minus 2 by x plus 1 equal to 0 if x is equal to 2. Now obviously x is not equal to minus 1, right? So this is the case. Now let's verify. Now that implies 0 less than or equal to x minus 1 by 2, isn't it? Now multiply 0 less than or equal to x minus 1. X minus 1 greater than or equal to 0. So x greater than or equal to 1. Now what is the intersection of these two? X greater than or equal to 1 and x equal to 2. Obviously x equal to 2 only, right? That is the only value. So x equal to 2 in this case. And we are left with third case. First copy this one. Why x equal to 2, sir? Vishwas Joshi. Signum of x minus 2 by x plus 1 is equals to 0. Definition, when this is equal to 0, right? X minus 2 by x plus 1 equal to 0. Now x minus 2 by x plus 1 equal to 0 means what? X minus 2 equal to 0 only, right? Isn't it? So definitely x is equals to 2. When does x minus 2 by x plus 1 will be equal to 0? When x equal to 2. Is it clear? Okay, good. And please revise all the topics from the beginning as you have term test, right? This weekend. Starting from sets. 2 chapters, sets, relations and functions. So tomorrow I'll try to complete greatest integer function, and after that I'll try to concentrate more on questions on logarithmic functions, because we did solve much questions, right? Logarithmic function, modulus function, and combination of these functions. Copied. And here is this case 1. And finally, case 3. What is case 3? Minus 1 to, if signum of x minus 2 by x plus 1 equal to minus 1, then x minus 2 by x plus 1 will be less than 0. Isn't it? Definition. So that implies signum of x minus 2 by x plus 1 equal to minus 1 if, when does this x minus 2 by x plus 1 is negative? When it is lying between minus 1 to 2. So when x is lying between minus 1 to 2. Correct? Now if you substitute minus 1 here, minus 1 less than or equal to x minus 1 by 2. Now multiply with 2. Minus 2 less than or equal to x minus 1. X minus 1 greater than or equal to minus 2. X greater than or equal to minus 1. What is the intersection of these two? Very simple. Minus 1, 2. This is minus 1 to 2. Both are open intervals. And x greater than or equal to 1. This one, isn't it? Or I draw it here itself. This is greater than or equal to 1, isn't it? What is the intersection of these two? Obviously, again, you'll get the same thing. Minus 1 should not be included, because here minus 1 is not included. We are taking the common region. Is it correct? So, what is the intersection? Minus 1 less than x less than 2. So, this is one solution. Therefore, this is one solution, this is the another one, and this is the third one. Therefore, finally, answer x belongs to minus 1 to 2, open interval, union 2. I am writing it in order. 2, union 3 to infinity. I hope this is correct. Or more precisely, I can write this one as x belongs to minus 1 comma 2 also we are including, right? So can I write it like this, closer to, by combining these two. Instead of writing this one separately, I am writing it as my open minus 1 to closed 2. Union 3 to infinity. So this is the solution set for this example. Please let me know if you have any confusion in this problem. Second, we are using it right here in solving the inequality. Actually, we do not know the value of this one, right? That's why we are considering 3 cases. Because it could be equal to minus 1 or 0 or 1. So if you take 3 different cases, if you solve, we got the solutions. 3 cases, 3 different solutions. So why you took union? Because see, we are considering 3 cases, right? Om Sai and Vishal. When you are considering different cases, the meaning of that one is either or, either case 1 or case 2 or case 3. That means it could be equal to 1 or R is very, very important. 0 or minus 1. So that's why I am taking union. Union means or, either case 1 or case 2 or case 3, because we got 3 different solutions. So then when intersection is taken, it is like when you are taking 2 values simultaneously. Maybe if x equal to 1 and x equal to 2, something like that. You will understand when you are solving the question. Tarun, no sir, if you include 2 in case 3, 2 in case 3, 0 is less than 0. I am not including 2 in case 3. I am including case. Actually, I got 2 in case 2, Tarun. Understood? I got 2 in case 2. And I got minus 1 to 2 in case 3. So union, right? So I am just clubbing these two. If you substitute x equal to 2 here, what will you get? 2 minus 2 0, right? Signum of 0 0 less than 2 minus 1 by 2 1 by 2. Definitely 0 is less than 1 by 2, less than or equal to 1 by 2. No confusion. No problem. If you include 2 in case 3, no, you should not include 2 in case 3, right? In general, we are including case 2 to the original problem. You should include 2 in the original problem, Tarun. Don't get confused. Case 3 solution is only minus 1 to 2. Case 2 is x equal to 2. Case 1 is 3 to infinity. So I am taking the union of these three. So x equal to 2 is to the original problem. And all the solutions, in fact. You should not club case 3 with case 2 or case 2 with case 1. 3 are distinct. Understood? Okay. Good. Now let me solve one more question before I close. Solve the equation. This is also one of the good applications. Right on. Solve the equation x square minus 5x into signum of x square minus 4 plus 6 equal to 0. Quick. Solve this equation x square minus 5x into signum of x square minus 4 plus 6. So again, it will play the crucial role in this question. Again, what I should do? Take 3 cases again. Solve it. Isn't it? Take 3 cases. Equal to 1, equal to 0, or equal to minus 1. If you know it, just keep solving it, I'll explain. Case 1. If signum of x square minus 4 equal to 1, then what is the inequality? X square minus 4 will be greater than 0. And what will be the sign scheme for x square minus 4? X plus 2 into x minus 2. Minus 2 plus 2. This is plus, minus, plus. Is it correct? Now, that implies signum of x square minus 4 is equals to 1 if x square minus 4 greater than 0 means x less than minus 2 or x greater than 2. Understood? So whatever solution you are getting, it should satisfy this restriction. Therefore, if you substitute here x square minus 5x plus 6 equal to 0, because this is equal to 1, right? Now if you factorize this one, x minus 2 into x minus 3 equal to 0. Simple quadratic equation. Now that implies x equal to 2 or x equal to 3. Now you have to verify whether x equal to 2 belongs to this interval or not. Does it belong to this interval? No. Because we have greater than 2, not equal to 2. And less than minus 2 also it does not belong. So x equal to 2 cannot be taken as the solution. I hope you are following. And what about x equal to 3? Yes, x equal to 3 is greater than 2. Therefore, only solution in this case is x equal to 3. So you please solve case 2 and case 3. I'll explain tomorrow. Thank you so much. That's it for today.